All right, so when we are adding, subtracting radicals, you can think of adding, subtracting radicals just like you would any two terms. In order to add and subtract, you have to have like terms. So let's recall, if I had 6x minus 2x, can I subtract that? Yes, because they're like terms, and I would say 4x. What if I had 6x minus 2y? Could I subtract those? No, because they're not like terms. So you can think of radicals as the same way, right? This x's, they match. That has to be the same thing with radicals. They have to match in order to add and subtract. So since these are both cube root 3, cube root 3, I can do 6 minus 2, which is 4, and I'd say 4 cube root 3. Okay? But if you look at 14, this is 14 square root x plus 3 square root y. I cannot add those together because this is a square root x and this is a y. They don't match. Even though they're both square roots, they have to have the same thing underneath also. Okay? So that's simplified. There's nothing I can do with that. So it's not a no solution. You wouldn't write no solution. It's just, it's done. There's nothing I can do. Okay? You look at the other two. Can I do number 12? Can I do 4 square root 3 plus 4 cubed root 3? No, because even though the 3's match, this is a square root and that is a cube root. You can't do anything with that. Okay. How about 15? Can I subtract these? Yes, because they're both cube root x squared, cube root x squared. So those are like terms, so I can subtract. 7 minus 2 is 5, so I'd say 5 cube root x squared. Okay. So then when you look at the one below it, your initial thought might be, I can't add those together. But you need to simplify, because maybe they are like terms, we just can't see it. And what do I mean by that? That means if I'm doing the square root of 18, you should recognize, hey, there's going to be 2 of something in there. I can take 1 out. Because 18 breaks down 9 and 2, and 9 is 3 and 3. There's 2 3's, I can take 1 out, and I have a 2 left over. Right? If I do that, the same thing with 32, 8 and 4 is 2 times 4. There's 2 4's, I can take 1 out. 2 doesn't have a partner, so it stays. So by simplifying both terms, now they are like terms and I can add them together. So sometimes you have to do a little bit of work first to see if they're like terms or not. So then I'd keep going. 3 plus 4 is 7. So I'd have 7 square root 2. Okay. Let's try another one. So again, at first they look like they're not like terms, but let's simplify. 20 is 5 and 4 is 2 and 2. So 2 2's, I take 1 out. That's going to get multiplied by the 14. So it's 28 square root 5. And then 125 is 3 5's. Right? 5 cubed is 125. So I'm going to break it down right away. Here's 2 5's. I can take 1 out. That's going to join the 3. So minus 15 root 5. Now, look, they're both square root 5. So they are like terms and I can subtract. 28 minus 15 is 13 square root 5. Okay. Let's try some cube root fourth roots. Okay. So cube root, the only thing different with cube roots is instead of 2 of something, I now need 3 of something. So 81, let's break that down. 9 times 9. And each 9 is 3 and 3. So I need 3 3's, which I do. 3 3's, I can take 1 out. That joins that 3. So 9 cube root 3. 54 is 9 times 6. 6 is 3 and 2, and 9 is 3 and 3. So again, there's 3 3's. That joins the 2. So minus 6 cube root 2. So I simplified both terms, but what happened? They are not like terms, so that's as far as I can go. I can't subtract them. I'm done. That's as far as it goes, as far as it simplifies. Okay, let's try fourth root. So fourth root, again, I'm looking for 4 of something to take 1 out. So 32, 8 and 4. 8 we know is 2 times 2 times 2, and 4 is 2 times 2. So I have 4 2's, I can take 1 out. So there's my group of 4. Take it out. What's left? That 2, so fourth root 2. And then 48 is 4 and 12. 12 is 4 and 3. And each 4 breaks down into 2 and 2. So there's my group of 4. Take 1 out. And then what's left? The 3. And then I'm done. They don't end up being like terms. So I simplified, and that's as far as I could go. Now that I've studied multiplying, and now that I know how to add and subtract, now we can do foiling of these numbers, because foiling requires multiplying and adding like terms. It does both. Okay, so now I can take those 2 operations and put it together and do FOIL. So if you remember FOIL, I take the first term times both. So 3 times 1 is 3. 3 times square root 5 is 3 root 5. Okay. And then I take the second term times both. So square root of 5 times 1 is square root of 5. Square root of 5 times square root of 5 is square root of 25, which is 5. Right? You can do that in your head. Okay, good. And if you notice, my first and last term I can combine, 8. And my middle 2 terms, my outer inner, can combine. 3 root 5 plus 1 root 5 would be 4 root 5. And then I'm done. Okay, let's try another one. Okay, so again, FOIL, I take the first term times both. So 2 times 1 is 2. 2 times 3 root 7 would be 6 root 7. And then I take the second term times both. So like this, root 7 times 1 is root 7. And root 7 times 3 root 7 would be 21. How'd I get 21? You guys do that in your head? This is what you're doing. Square root of 7 times 3 square root 7, which would be 3 square root 49. Because 7 times 7 is 49. What's the square root of 49? 7. So I'm really doing 3 times 7, which is 21. And again, if you notice, your first and last add together. So 21 plus 2 is 23, and then your outer inner terms, your middle 2 combined together, 6 root 7 plus 1 root 7 is 7 root 7. Another thing we're going to look at is squaring a binomial, and hopefully you know squaring a binomial would just be basically a FOIL. It's just written in a different way. We look at binomial squareds a lot because when you get into upper level mathematics, you work with binomial squareds quite a bit. So it's just practice with working with them. So what this squared means is that you just do it twice. Right? Squared just means multiply the same thing again. And then it turns into a FOIL. I take the first term times both. So square root of 3 times square root of 3 is the square root of 9, which is 3. Square root of 3 times square root of 5 is the square root of 15. And then this term times both. Square root of 3 times square root of 5 times square root of 3 is square root of 15. And then square root of 5 times square root of 5 is square root of 25, which is 5. And again, if you notice, the first and last are going to combine, 8. And your outer inner, your middle 2 terms combine, and that would be 2 root 15, because there's a 1 in front of both of them. So 1 plus 1 is 2, and then square root 15. have one more of those and then we'll get into the second part. Okay. So again, squared means just twice, right? You're just doing the same thing, multiplying it together. So I'm going to take the first term, square root of 13 times both. So square root of 13 times square root of 13 is 13. Square root of 13 times 6 would just be 6 root 13. And then you do the inner, so 6 times square root of 13, it'd be again 6 root 13, and then 6 times 6 is 36. And what you should notice, again, first and last are going to combine, so 49. And then your middle two terms, your outer inner, would be 12 root 13. So we did multiplying, and then we added like terms. So two operations go when we FOIL. So what I want you to notice about these next two examples is something kind of important. If you look at your next two examples, you should notice that they're almost identical. The only thing that's different is the sign in front of the radical part. This is a negative root 11 and that's a positive root 11. Okay? Those are called conjugates. And we studied that a little bit with quadratics. Because remember when I told you if square root of 3 is a root, you have to have negative square root 3. They always come in conjugate pairs. If we had 1 plus 2i, we have to have 1 minus 2i. If I had 4 plus 5 root 3, I have to have 4 minus 5 root 3. Those are called conjugate pairs. And when you do quadratics and polynomials, you always get conjugate pairs. Okay? So I want you to notice something in these next two examples. We're going to FOIL them, and we're going to see what happens when you multiply conjugate pairs together. Okay? So 5 times both. So 5 times 5 is 25. 5 times square root 11 would be 5 root 11. And then the second term, negative root 11 times 5 would be negative 5 root 11. Negative root 11 times positive root 11 would be negative 11. Okay. Now again, your first and last terms are going to combine, and that's 14. What happens to my outer inner terms, my middle terms? They cancel out. So when I multiply conjugate pairs together, my radicals go away. Okay, let's see if it happens again. Okay, so again, these are called conjugate pairs because this is a negative 2 root 3 and that's a positive 2 root 3. Right? The radical part has opposite signs. So let's FOIL. 4 times 4 is 16. 4 times 2 root 3 is 8 root 3. Inner, so negative 2 times 4 would be negative 8 root 3. And negative 2 times positive 2 would be negative 12. How did I get negative 12? If I have a negative 2 root 3 times a positive 2 root 3, that's negative 4 times the square root of 9. 3 times 3 is 9. But what is the square root of 9? 3, and that gives me negative 12. Okay? So I'm challenging some of you to try to do that in your head. It'll save you some work. Okay? So again, first and last combine. 4, and what happened to my outer inner? They canceled out. Okay? So why is that such a big deal? Because when we're rationalizing the denominator, we rationalize the denominator to get rid of any square root on the bottom of a fraction, right? Okay? So yesterday when we were rationalizing the denominator, we were working with a denominator that was only one term. Now I have a denominator with 2 terms. So I can't just multiply top and bottom times square root 3. That's not going to work anymore. Because look, if I multiply this by square root 3, I still end up with a square root of 3. Right? If I multiply both. So that doesn't work. So if I have 1 plus square root 3, and I need to get rid of the radical, what can I multiply by? The conjugate. I can do 1 minus square root 3. If I take two terms like this, right, I can multiply by its conjugate pair, and that's going to get rid of the radical. But if I multiply the bottom times 1 minus root 3, I have to multiply the top times 1 minus root 3. Okay. So on top here, that's going to be a distribution. Just the 4 is going to get multiplied by both. So 4 times 1 is 4. 4 times negative root 3 is negative 4 root 3, right? And on the bottom, and here's the shortcut since we already did a couple examples, my outer inner terms always canceled out, right? So I don't have to do outer inner because I know they're going to cancel out. So when I'm multiplying conjugate pairs, all I have to do is multiply first and multiply last. Because I know FOIL, outer inner cancel out. So I just do first and last. So 1 times 1 is 1. Square root of 3 times negative square root of 3 is minus 3. Simplify that. 4 minus 4 root 3 over negative 2. And just like working with quadratics, you should notice that these are all divisible by 2. So I can go one more step. Negative 2 plus 2 root 3. Okay. That's simplified. What I want you to know is that if I put this in my calculator, 4 divided by 1 plus square root 3, and I get some kind of crazy decimal thing, right? And I put negative 2 plus 2 root 3 in my calculator and get some crazy decimal thing, those are going to be the exact same decimal number, right? It's just I made this look nicer. If I were to work with a number, I'd much rather work with this number than that number, because that has a fraction first of all, and then this crazy square root on the bottom, and I don't know what's going on. Okay, so simplifying by doing this, it simplifies a number into a better looking number. You still have the same value, it just looks better. That's all you're doing. Okay, let's try another one. We'll go back to that one. Let's go to this one. Okay, so on the bottom I have 2 minus 2 square root 8. I need to get rid of that square root of 8. So I multiply the bottom times what? 2 plus 2 square root 8. Very good, by its conjugate. Yep. So this one's going to be a FOIL on top and bottom. Okay, so let's FOIL the top. 3 times 2 is 6. 3 times 2 root 8 is 6 root 8. And then the square root of 8 times both, so 8 times square root of 2 is 2 root 8. And then square root of 8 times 2 square root of 8 would be 2 times 8, which is 16. Okay? Because I have a 2, and then square root of 8 times square root of 8 is 8, so 2 times 8 is 16. Okay? And then the bottom, I'll just FOIL first, then simplify. The bottom, remember, since they're conjugates, I only have to multiply the first and the last. I don't have to do outer inner. So 2 times 2 is 4. Negative 2 root 8 times positive 2 root 8 is going to be negative 4 times 8, which is going to be a negative 32. Everybody do that in their head? Negative 2 times 2 is negative 4. Square root of 8 times square root of 8 is 8. So it's negative 4 times 8, negative 32. And then I can simplify. 6 and 16 is what? 22. 6 root 8 plus 2 root 8 is 8 root 8. And then what's 4 minus 32? Negative 28. And then am I done? I can go one more step because, right, all of these I can take a 2 out of. So final is the 11 plus 4 root 8 all over negative 14. Then that's done. More, just so you recognize what a conjugate is, okay? So if I have 3 root 3 minus 2, what's going to be my conjugate? A conjugate always changes the sign of the radical part. So my conjugate is not going to be plus 2, it's going to be negative 3 root 3 minus 2. I just changed the sign on the radical part. So even if it's flipped around, be careful. Just the radical part gets changed, right? Okay, and then I can go ahead and multiply. Right, take 4 to both, so that'd be negative 12 root 3 minus 8. And then on the bottom, again, since they're conjugates, I only have to multiply first and last. So 3 root 3 times negative 3 root 3 is going to be negative 9 times 3, which is negative 27. And then last, negative 2 times negative 2 is positive 4. So then simplify the bottom. I get negative 23, and that 23 is prime, so I'm done. Okay. If I wanted to go one more step and make all of these positive, that probably looks a little bit better, but you don't have to, since they were all negative. Negative divided by negative is positive, and I can switch all of those around.